Hello everyone. In my previous video, I started the Telangana Polytechnic Common Entrance Exam 2025 question solutions and all. In previous class, I discussed these questions. Now let us see the fifth question. The number of magnetic quantum numbers for angular momentum quantum number L value is equal to 1. They're asking magnetic quantum number ml. We have L value 1. So ml is nothing but we have minus L2 plus L. We have the values. So minus 1, 0, plus 1. So how many? To the total 3. Otherwise we have one more formula is also there to know total number. To know total number of ml values, we have 2 L plus 1. That is, what is L here? 2 into 1 plus 1. This is also 3. Likewise, we can solve anything. So, answer is 3. Sixth question. The law of octaves was proposed by. So, what is Dauberner given? Law of triads. Mosley has given the atomic number. Atomic number and modern periodic table also. Modern periodic table. Why I am telling all the options? No, if you learn the concept in the next exam, if they ask you which of the following scientist has given the modern periodic table, so mostly if you learn here itself, it will be very useful. With concept, try to learn. This is Mendeleev given the periodic table based on atomic mass. Based on atomic mass. Newland has given the law of octaves. So law of octaves is given by Newland scientist. So this is the answer. The number of elements present in fifth period of modern periodic table. They have given fifth period. Fifth period means principal quantum number n equal to 5. So how to calculate number of electrons? To calculate number of electrons, we have ns, n minus 2f, n minus 1d, and then np is there. So here, substitute here 5s, and then 5 minus 2, 3f, and then 5 minus 4d. We have np. np is 5p. Now let us try to see 3f is existing or not. See, n equal to 3. L equal to n minus 1. N minus 1, 3 minus 1 is nothing but 2. So whenever it is 2, then usually this angular momentum quantum number represents, if L equal to 0, that is s orbital. L equal to 1, that is p orbital. L equal to 2, that is d orbital. L equal to 2 is a d orbital, which is not an f orbital. So that's why this doesn't exist. Now coming to this 4d, n equal to 4. This is a principal quantum number, this is a principal quantum number, but L equal to angular momentum quantum number is n minus 1. So what is n? 4 minus 1. So then 3. 3 means L equal to 3. Whenever L equal to 3, definitely there is an existence of D. So D is possible. Now 5p is also possible, 5s is also possible. So n equal to 5 means L equal to 4. So definitely s and p orbitals are possible. Up to this, L equal to 2 means SPD is possible. L equal to 3 means SPDF is also possible, but here that is not the criteria. And then L equal to 4 means SPD. Likewise, these are all possible. But S occupies 2 electrons. D occupies 10 electrons. Why? Because we have DXY, DYZ, DZX, dx square minus y square, dz square, px, py, pz. So each orbital occupies 2 electrons. So total 10. Here each orbital occupies 2 electron, total 6. So 2 plus 10 plus 6, that is 18. So answer is 18 occupied by this fifth period. So number of elements present in fifth period. Number of elements, those are how many present? 18. So 18 elements are present. Up to 18 elements, those are present. Because number of electrons, number of outer electrons represents principal quantum number. That's why we are taken directly fifth period means principal quantum number. Otherwise in short also you can follow. Fifth period means in the periodic table. In the periodic table, if we are calculating, 18 groups are present. So then what happened? Definitely from first to hydrogen 1A group to last noble gases, 18 elements are present. That's in simply also we can easily solve. This one also including electrons we can solve. So anyway we can solve this question. Simple shortcut is fifth period. So 18 groups are present. Fifth period, 18 groups. Last periods all are having same elements. So then what happened? 18 elements are present. Which of the following has smaller atomic radii? We have elements fluorine, oxygen, nitrogen, carbon. According to atomic number, let us arrange this. Carbon, nitrogen, oxygen, fluorine. So then carbon 6, 7, 8, 9. If we are going along the period, atomic number increases, size decreases. So whenever size decreases, so atomic number, size decreases means atomic radii also decreases. So fluorine has this smaller atomic radii. Size decreases means definitely, obviously radius also decreases. So fluorine has the lowest atomic number. Atomic radii. Fluorine has the lowest atomic radii. Next question. Ionization energy generally dash from left to right. See in this question paper they are asking the periods questions in the periodic table from left to right. Whenever from left to right, generally what happened? The size is decreases. Whenever the size is decreases from left to right, it is very difficult to remove out. Ionization energy means the amount of energy required to remove the outermost electron. So whenever to remove the outermost electron from the smaller size, it is very difficult. Why smaller size difficult? Because nucleus is there. If it is very close to the nucleus, electron having negative charge, these two are strongly bind together. To remove the strongly bind electrons out of this atom, the amount of energy is ionization. It is very difficult if the size is very small. If the size is very small, attraction is more, thereby we cannot remove the electron. So more and more ionization energy is required for smaller sizes. So ionization energy from left to right increases. Why? Because size decreases. Size decreases, ionization energy increases. The predicted properties of Eka-Boron given by Mendeleev were almost same as of dash which of the discovered later. So in this we need to see, they are asking Eka-Boron. Scandium is Eka-Boron. Eka-Boron means the atom which is present below, which is also following the properties of boron likewise. For this we have gallium, we have aluminum. Germanium we have silicon. Likewise we have the Mendeleev predicted Eka-Boron is there, Eka-Aluminum is there, Eka-Silicon is there, nothing but gallium, germanium and scandium. So Mendeleev is saying that both are following the similar properties. Germanium, silicon following similar properties, gallium, aluminum following similar properties, boron and scandium also following similar properties. So boron they have given, that is wrong answer. Answer is Eka-Boron is scandium. Which of the following molecules is an example of sp2 hybridized? This question is very, very important. So I'll tell you the technique here. You can easily find any hybridization. So beryllium is nothing but we have beryllium 4 atomic number. So configuration 1s2 2s2 1s2 2s2, but 2p 0. Outermost electronic configuration is 2s. And then 2p is also available, but no electron is present. But in the first excited state, one electron jumps from the 2s orbital to 2p orbital. 2p orbitals. And then what happened? Chlorine share the electron with this beryllium and forms the two bonds. So here hybridization is nothing but bond pair plus lone pairs. Hybridization is nothing but bond pair plus lone pairs. How many bond pairs are there? Lone pair is not present. These are vacant orbital, not lone pair. Lone pair is nothing but a pair of electron which are not participating in bonding. So here two bond pairs are present. Two bond pairs. So two bond pairs means sp hybridization. So this is sp hybridization. Hybridization of this is sp. Now coming to BF3. Boron. Boron is having 5. 1s2, 2s2, 2p1. Outermost electronic configuration we are taking in bonding. So 2 electrons and px, py, pz, 1 electron is present. But in first excited state, ground state, usually atoms does not undergo bonding. So first excited state we have to take. First excited state, there is a jumping of electrons if possible. So now what happened? One jumping of electron is there. But boron with fluorine, 3 fluorines, it forms the bond. Fluorine forms the bond. Here also vacant orbital is there. How many bond pairs are there? 3 bond pairs. 3 bond pairs means sp2. 2 p orbital, 1 s orbital. Totally 3. 3 bond pairs is nothing but sp2 hybridization. So this is BF3. Coming to CH4. Carbon is having 6. 1s2, 2s2, 2p2. So outermost is 2s2, 2p2. So then what happened here? 2s, 2p. 2 electrons, 2 electrons. So then after that, this is ground state. First excited state. If you are taking first excited state, 3 electrons are here. But all these 4 electrons are participating in bonding with hydrogen. Forms the CH4. So how many bond pairs are there? 4 bond pair. This is pair in bond. Pair of electrons in bond is called as bond pair. 4 bond pairs plus 0 lone pairs. So totally 4. sp3. Now coming to the one more, that is ammonia. Let us see NH3 ammonia. So now what happened? Here ammonia nitrogen is 7. 1s2, 2s2, 2p3. So then outermost electronic configuration 2s, 2p3. 1, 2, 3. So then what happened? It is half filled. That's it is stable. At this stage only it is reacting with hydrogen. Then what happened? Here one pair of electrons does not participating in bond. This is what we call it as lone pair. So one lone pair plus how many bond pairs? This 1, 2, 3. 3 bond pairs. Totally 4. 4 is nothing but this is also sp3 hybridized. sp3 hybridized. So what they are asking? sp2 hybridized. sp2 means BF3. So answer is BF3. BF3 is the answer to solve this. Likewise, if you just know the atomic number of elements, we can easily calculate all the things. So very, very important technique. This is technique to find the hybridization. The chemical bond formed by overlapping of orbitals on internuclear axis. So this is what we call it as sigma bond. This is also fact-based sigma bond. Pi bond is because of lateral or sidewise overlapping. sidewise overlapping. What is this internuclear axis? They say, for example, this is px. Px orbitals undergo bonding. Then what happened? These two orbitals combine together, form a hybrid orbitals. Single hybrid orbital is produced. This is what we call it as internuclear. This is the axis. This is the axis. This is the axis. Along the axis only these two orbitals are undergo hybridization. So this is what we call it as the internuclear axis overlapping. Sidewise overlapping is nothing but if p orbital is like this, another p orbital is like this, then what happened? Because of this attraction, these two forms the bond. This is sidewise or lateral overlapping forms the pi bond. This is pi bond, this is sigma bond. This is the direct definition of the sigma bond, direct statement, no concept and all. So with this, I have completed some of the questions. In the next video, I will continue the remaining questions. If you have any doubt, comment below. Thank you.